In this example, we are looking to do the limit as x approaches 0 from the right of the natural log divided by cosecant of x. So if we were to plug in, let's kind of start off with, let's plug in 0 from the right. So we have to do kind of some graphs, and I'm going to take a look at. If I have, this is my natural log graph, my cosecant graph is graphing a sine curve, and then turning it into a cosecant. And so I have a cosecant, looks like this, looks like this. And so if I am plugging in a natural log and plugging in values that are getting infinitely close to 0, because I can't plug in 0, can't plug in 0 on either of them because they're asymptotes, I am getting a negative infinity over a positive infinity. All right, now that does not necessarily simplify out to a -1 because which one of them is moving faster, right? And I don't know, so the graphs are not going to tell me that. So I'm going to use L'Hopital's rule. So this is what I'm going to end up using because I have these situations that I can use it. If I have a 0 over 0, a 1 over 0, or an infinity over infinity, which is what I have, then I can do the derivative of the top. So I'm still going to be looking at some point to be doing as x approaches 0 from the right. And I'm doing the derivative of the natural log, which is going to be a 1 over x divided by the derivative of cosecant. And if I do the derivative of cosecant, I'm going to be, put it over here, derivative of secants and tangents, I'm going to use the right? So I'm going to spell out, but I'm not going to use the P. So this one is a derivative of secant is secant tangent, derivative of tangent is secant squared, but I can convert those into cosecant, cosecant, cotangent. And I'll put a negative because derivative of any co is going to be a negative. So the derivative of cosecant is negative cosecant cotangent. So negative cosecant cotangent. All right, so this doesn't seem that we got any easier, but let's see if we can do some manipulation, see what we got going on. That if I were to look at this again, I have the limit as x approaches 0 from the right of 1 over x. And this is -1. Oops, forgot my over x. 1 over x divided by -1 over sine times cosine over sine. So instead of writing it like this, I'm going to multiply by the reciprocal. So I'm going to take my limit as x approaches 0 from the right. And this x is going to be in the denominator. I'm going to multiply by the reciprocal. So these signs will come to the top with their negative, and then the cosine is going to be into the denominator with the x. All right, so on this one, I'm looking at now plugging in 0, but I have some things that are a little bit nicer, but I do get a 0 on the bottom, and sine of 0 is 0, so I'm getting a 0 on the top. So I can do the L'Hopital's rule again. So if I do that, I'm going to do the derivative of this. So this squares on the outside, so I'll bring the 2 down, so it'll be a -2 sine x, because the power would go to a 1. So that would be the derivative of the outside times the derivative of the inside, which is cosine x, over this is a product rule. So if I do the product rule on this, I'm doing the derivative of x, which is 1 times cosine x plus x times the derivative of cosine, which is negative sine. All right, So let's see. If we put all this stuff together, we are looking at the limit as x approaches 0 from the right of a negative 2 sine x cosine x divided by cosine x minus x sine x. All right, good news is I am not going to get a 0 in the denominator anymore because sine is going to be 0. This is 0. So that whole piece will go to 0, and cosine of 0 is 1. So I know I'm going to not get a 0 over 0. I don't need to do the derivative again. I can just plug things in. So I'll plug in 2 times sine of 0 times cosine of 0 divided by cosine of 0 minus 0 times sine of 0. And that is going to give us a sine of 0 is 0, so it's going to wipe away the whole top. Divided by cosine of 0 is a 1, minus 0 is 0 over 1, which gives us a final value of 0. So way back at the beginning, we were trying to find the limit as x approaches 0 from the right of the natural log divided by cosecant of x, and that limit would give us a 0.